Thank you for joining the intro to deephouse.io, and we present a telehealth use case demo. So your company wants to have an analytics capability, and the data engineers find themselves going through the same routine of developing an ingestion schema model, table mapping and storage, and the list goes on. It's not a win-win situation for the company or the engineer, as they take more time to market and the engineers lose interest in the whole product, eventually leading to failure. I'm not joking when I say DeepHouse.io is a byproduct of a few frustrated engineers who have seen themselves repeat tasks for preparing, storing data, and transforming using numerous tools. We obviously are cloud native end-to-end platform that will automate your data pre-processing, feature engineering, analytics workflow, and storage solutions. We have a large vision of making all this self-service so you can take it, use it for your use case, use it as your backend service engine for analytics, or use it for exploration or testing. Folks, data, as we all know, will only get larger, and use cases will only increase in number. Deepos.io is starting its journey to end analytics design chaos. Telehealth has become popular in the recent years, so we will use that as our use case, in particular ECG monitoring. With the development of wearable tech and mobile phones, extending telehealth beyond Zoom calls to your doctor's office is already taking shape. Traditionally, we go into the doctor's office and get the ECG done. If you do not end up rescheduling your appointment, that is, it's not always good enough to help save lives. Small changes from regular norms can help capture health in better way. And there are few companies out there on this to reduce the amount of time spent in analysis of ECG waveform while you are in the comforts of your daily activities. Let's imagine one such company who wants to extend their SaaS offering to this use case, starting with a POC and taking it to production in case it's well received by the decision makers. And that is all about time to market with minimum amount of overhead. DeepHouse.io provides a solution through its simple but interconnected services. Let's narrow down the problem statement and the solution in the next slide. I'll let you read through that. For our demo, we will use ECG files in the native formats of atr.hea.dat obtained from PhysioNet. Typical workflow is illustrated here. Patient files are collected as a central location of the company, needs to be pushed to the deephouse.io based analytics engine. The folder monitored will push data to S3 AWS Cloud, then gets converted to S3 format, gets the schema of the file, model it, ingest, explore the data, and analyze using ECG and statistics, create machine learning models, maybe retrain the models, use the existing models to a certain possibility of abnormal beats where files do not have such annotation, and in the end provide all of it as an automation so that it can be updated to your client dashboard, trigger emails and notifications, another connector. Suddenly we are able to see a light at the end of the tunnel for otherwise a large undertaking. The engineers and the company are happier. We'll achieve the above in Deep House using two-stage process. Nothing too fancy. We call it the template and automation phase. Template phase sets up the whole workflow end to end using the CSV files. During the automation phase, the whole manual work that we set up for the templating is automated end to end. This will make it whole worthwhile if we go through a quick demo. And stick around till the end, folks, because we will go through each and every feature to make it. So let's get right into the demo of an ECG monitoring use case for telehealth. I'll use the default user, log in directly into the platform. And right away, we should be able to see the other projects that are run tested, and we'll use a pre-processed data set to go through the steps of templating phase. And as you can see, um, this is a particular case where you have a couple of CSV files, mostly ATR and P signal files from different patients, and that is denoted by the number. This is from the PhysioNet dataset. It's converted from a binary to a CSV using a Python code, which will be used in our automation phase as well. So once in a CSV file format, we will be able to upload get, get a preview at this stage, and then we go to the next step where we should be able to pick up the storage solution of PostgreSQL, and you can see the preset readers for the CSV. Once we are done with the readers setup, how the CSVs are, we will go to the third step of the schema mapping, where the schema of the CSV is auto detected, and you can see it's a completely simple one-to-one mapping. No transformations have been done. If a transformation has to be carried out, you could write a script here, and that should be helpful for doing transformation. If you want to add columns, you can do that at this stage as well. So there's a lot of flexibility built in. There's also the preview button, which will help you get you the preview, and you can see this the file, select the schema for the ATR 100 file, so that will be helpful to distinguish the patient information as well. So the last step is the processing, and there'll be a bunch of files which are already processed, so we'll go directly into the explore phase, explore section, and under projects, and here we'll just go directly to the project that we were interested in, and you can see the uh, metadata of each of these of the model along with the preview, and you should be able to query, and we'll be using a simple SQL query for now, and not the language agnostic that should be done at the later stage. So I'll take some of the queries, such as the one here, to demonstrate how the query will run and get a data, and you can plot that if required, and you can see the one heartbeat from the data and if all the data has to be plotted, that can be done as well. Currently the zoom feature is not enabled, which will be enabled going forward. So the saved queries become the basis for the next section, which is the workflow. Here's another use. There are many functionalities here, like the join can be added. There's also, you can bring out schema, sorry, the statistics and other basic modeling and exploration can be done. So this is great for the engineers to take it from ingestion, uh, study the data, and take it to analytics. And talking of the analytics, let's go to straight into the workflow. And in workflow, pick up the project that we were interested in to demonstrate the stats being generated using the P signal that we saw. It involves designing using a bunch of pre-built components, and in this case, there's a Postgres reader processing for for Python script and an output to Postgres as well. So in these nodes, you could add your script under Postgres custom, and with Python, so what is that can be added as well in the operator, or it could be a SQL case. um, if there's any libraries that is needed to be imported for the Python, that could be available through this section. Any environment variables to enable automation will be as well included in this. So this is also part of the documentation in of the product. And the save query, we can input for the input data. The save queries can be added here as our input, and we saw that we could use the join case for machine learning project, or just the p signal in case we want to do a simple statistics in this case. It's as like in this case. One other feature is the test mode, where you can switch over to the test mode, and you can see how well the data the workflow will work out. And you can also take a view of the intermediate data set. For example, here we have the ingested data and the transformed data to the BPM and so forth. The space left here for visualization, which would make it extremely useful for the data engineer. Also, you would notice there's a version involved here, and the version, if you want to have multiple versions with different parameters to be tweaked, and we can compare the version, so it'll be again very useful for the data engineer in this modeling phase, or the template phase, as we call it. We can switch over back to the regular mode, and you can see a couple of runs that were done, was successfully done. And if there was any kind of error, we should be able to see the logs, and that should help us fix our errors and during this sort of a development phase for the data engineer. So going back to one more quick sample of the machine learning example that we talked about, um, where if you are interested in getting new data set and determining if there is any alerts needed, for example, in terms of unusual activity in the heart rate, then there is a model that we have saved as a pickle, and that can be used for outputting any alerts for a specific patient. So how do we generate that model? The model can be generated uh, through the modeling phase, which I'll bring it up here. Right. This is a workflow to show that. Here is an example of the script with a Python script where the samples join. This is the case where the P signal and the ATR signal are joined and used to combine and figure out if there is for the abnormal heartbeat uh, versus a normal heartbeat, and that model is saved as a pickle file. So which was used in the previous workflow. This is because we can include both projects and workflows as our input to this workflow. So it adds a lot of flexibility for the data engineer while modeling more complex use cases such as this. Um, so that is a quick overview of the workflow. Well, one of the other features is once we have this data set, well, I would like to visualize it on my, because this is my analytics as a search engine, maybe sorry, analytics as a service here, or it could be this is a proof of concept engine, and you want to just visualize on a third party uh, tool, or you have another website, for example, your client's website, and you want to embed those and that in their website. So for that, we're providing REST API calls to the dataset, and that again can be done through the workflow or the projects by selecting those. That will help. That provides the key to getting the API that is needed to generate our generate the dashboards. So here I've clicked the generate API, and you have a URL which we will use in. So here we have the screen from the Grafana where I'm using those API calls from the data connector to show the stats and just the straight down P signal from the projects. So this is from the workflow, this is from the projects. So the output from that is plotted here. So this could be in Grafana, could be other softwares like Looker, Tableau. So it provides a great service for all those use cases. So if you have mission alerts, we can now set up alerts here to see if there's a threshold that we cross. So it becomes a complete end-to-end solution. Uh, ne- Next, we will move from the templating phase to the automation phase. We will just show that we will use the S3 for now, since the current Deep House UI doesn't have support for S3 yet, but we do have that in our plan to make it completely go through the Deep House UI. So the S3 on AWS will be used for the automation phase, in which case the binary files will be uploaded and which will be converted to CSV or automatically and then fed through the whole pipeline from ingestion to the end results which we saw on the through the dashboard. So it completely hosts the whole solution in the backend through deep house. So in this sample, let's say we have to upload a couple of HEA files. Let's take on 5 patient, upload that, and at this point it will be uploaded, which will trigger the Python script to convert it to CSV, and which in turn the whole pipeline that we set up during templating will kick in, and it will again trigger the workflow needed. For example, the stats workflow, the learning workflow, and modeling. And if there's any alerts, it will be displayed at the dashboard. So that's the end-to-end solution that we are going for. So then now let's see if this was uploaded to our project, which will be able to see if the 105 was uploaded. Give it a minute to get to that data, and you can see that the 105 PSV file, the PC 105 and AT 105 CSV were uploaded, and it'll be now part of the stored data in Postgres, and it should have triggered workflow models and so forth. And this concludes our quick demo of the ECG monitoring use case for telehealth. Um, there will be more use cases that we're going to be working on, and we will provide more audio and video, rather video demonstrations as well soon. Thank you for listening.